I sit down. Hello, am I audible? Hello. Divya sir?
Yes, Aditi, you are very much audible.
Okay, thank you, ma'am. Good evening, everyone. Welcome to the SOAWAL webinar, episode 3 today of our weekly webinars with eminent speakers from higher educational institutions. Today we have my very own senior from NIT Rourkela, Dr. Prasad Padhy. So we are very obliged to you for joining us here for our talk, sir. I would like to start with introducing our university, which is Shiksha Anusandhan University. I would like to start with introducing our university to us, and for everyone present here, before going to the intro video, I would like to talk about Dr. Padhy a little bit. He is currently serving as an assistant professor in the Department of Computer Science and Engineering at the Indian Institute of Information Technology, Design and Manufacturing, Kancheepuram, India, IIITDM, Kancheepuram, India. He has received his BTech degree from National Institute of Technology, Rourkela in Computer Science, as well as his PhD degree from National Institute of Technology, Rourkela in Computer Science. He has 5 years of cumulative industrial research experience with Samsung Research Institute, Delhi, and also he has worked with Siemens Technology and Services Private Limited, Bangalore. His research interests include machine learning, computer vision, autonomous robotics, visual surveillance, etc. His research publications comprise many international journals, many reputed conferences. He also has a lot of patents in all these domains. He has served as a reviewer in many peer-reviewed international journals and conferences. So that is a brief introduction about Ram sir. Again, thank you, Ram sir, for joining us. Now I would like to start introducing our university. Somebody please let me know if my audio and video is okay. So this is a brief introduction of our university, Shiksha Anusandhan Bhubaneswar. We are deemed to be university located in Bhubaneswar, Odisha. And here goes our introduction.
Aditi, please check the video and
Video is not visible. Sorry, I'm so sorry. I'll just start it again. Is it visible now? Okay,
Yes,
I'm so
Aditi,
sorry.
please.
I'm so
Yeah, it's
sorry,
okay.
everyone. Somewhere to join Palla, So that was the introduction of our university. Now we can move towards our main presentation or webinar today. Ram sir, you may share your screen and please start the presentation.
Yeah, sure. One second. Let me know if you can see my screen.
Yes, we can see your screen.
Okay. So thank you, Dr. Aditi, for such a nice introduction, and I also thank the whole SOAWAL-CSE community for inviting me for the lecture on artificial intelligence for self-driving cars. I hope this lecture will kindle some interest among the participants to start the research in this area. Okay, so without wasting much of your time, let me start this topic. This topic is artificial intelligence for self-driving cars. You see, there are two emerging topics that are connected here. One is this artificial intelligence, one is this self-driving cars. Okay, so when you think about artificial intelligence, you can see it everywhere, be it academia, be it research, be it any industry, anywhere you go, they say that we will use some artificial intelligence. Even you can see this Government of India initiative, everywhere artificial intelligence is something that everyone is want to get a hold on, and they want to use this area to get their work done, be it business, be it research, anywhere. Okay, then there is this term self-driving cars. Okay, you might have heard from different companies like Tesla, where Elon Musk is trying something, and he got this up to level 4 or level 5 autonomy, or some other companies such as Google, or let's say there is this other companies who are coming up with these self-driving cars. Okay, although we have not reached to a stage where the self-driving cars are actually a reality on the road, I mean, when I say reality means out of the testing condition coming actually on the roads, okay, that is still not feasible. But still, people are working day and night to make this as a reality, and I am sure that by 2030 we will reach at a stage where the self-driving cars are actually a reality on the road. Okay, along with the humans and other even driving cars, okay, driving and self-driving cars collaboratively on the road. So you see, there are two emerging areas that are connected here, and that's why I'm working on this research area, which is very if you think about the future, this is very useful. Okay, so here I am going to cover about some introduction about the self-driving cars and artificial intelligence. Then we will look into why artificial intelligence is so much important for the self-driving cars. Then we will see different kind of sensors that are being connected to the cars and how the data that is coming out of this self-driving cars are actually used in artificial intelligence algorithms. Then we will see different kinds of sensor fusion algorithm and what are the data sets that are existing in this area. And if we get some time, then I have prepared one demo for you that also I will say. Okay. So the first question is, what is a self-driving car? Okay, when something comes about self means it is automatical. Okay, you can think of autonomous. Okay, when you say about autonomous ground vehicles, this is something which is not operated by humans, that is moving autonomously. When you think about the autonomous unmanned aerial vehicles, you think about some drone that is moving autonomously without actually taking the help of humans. That is just a piece of software is written by which they are able to move autonomously. Same thing for self-driving cars. You can think of it as a autonomously moving ground vehicle. Okay, so self-driving car means a vehicle that can be moved autonomously without the help of the humans. Okay, so you think of the human beings, how the human beings actually move in the vicinity. They have different sensors that are being connected to their body, biological sensors like this eyes we have touch sensor, we have other sensors like 5 sensors we have. Using those senses, we want to perceive the environment. Now, after perceiving the environment, then we know that, okay, these are the things that are there in the environment, and we try to locate ourselves in the environment. That is what is localization. Okay, so the same concept applies for the any robot, not only self-driving cars, any robot that is there, any autonomous vehicle that is there. Okay, so using some different sensors that are being connected to the vehicles or robots, they want to perceive the environment, and after perceiving, they try to locate themselves with respect to others in the environment. That is what is self-driving car also does, right? So different sensors such as this LIDAR, radar, GPS, IMU, camera, all these sensors are connected to the vehicle, and using those sensors, the data coming out of those sensors, the self-driving cars try to locate itself with respect to others in the environment and tries to move forward without colliding others. Okay, so when we think about self-driving cars, it is not only about just one car, but as you can see in this picture, there are all different self-driving cars. Okay, so it's like a fleet of self-driving cars that are moving, and this is still not what you say in the roads. It is still not feasible, but people are working day and night to make it as a reality. Okay, so this is just a gist about what are the self-driving cars, and this market is growing like very fast. The cumulative average growth is predicted from 2019 to 2026 is 39.5%. So you see how this global economy is somewhat dependent on this concept of self-driving cars. Okay, so we have reached to a stage. We started around like 2013 or 14. People started a little bit of doing this, giving the autonomy to the cars, and now we have reached to a stage where we can say that we have reached up to 50-60% of autonomy, and by the year 2030, I think this is a reality that is going to happen. Okay, in some cases you will learn, you will hear this term as autonomous vehicles and advanced driver assistance systems or ADAS systems, which are just the names of self-driving cars that the people use in research domains. Different marketplace such as the General Motors, Dynamo, or all different companies. I think some of you must have heard like this Tesla and this Toyota Motors and Renault. All these companies are working day and night to make the self-driving car industry much more feasible. Okay, apart from the key market players who are working on the making the cars, apart from that, there are other companies who provide the different parts to the self-driving cars. Along with that, there are different software making companies who make the actually brain of the computer. That is where the artificial intelligence comes into picture. Then the service provider companies such as this Uber, Lyft, the Xiaomi, all these companies are there. Okay, so all of them make this self-driving car industry a more what do you say emerging technology. That is why you can see in the previous slide, as I told, this cumulative average growth is 39.5%, which is predicted from 2019 to 2026. Now, when you go to the different levels of autonomy that is there in self-driving cars, it is basically divided into three different parts. One is the what you can see, one is the assisted mode, second one is the automated mode, and third is the autonomous mode. Okay, here you can see that there's a mode that is not included because that is where there is no autonomy is there. That is what is the driving car is, where the driver actually drives on the road. That is what we are currently seeing on the road. Okay, that is where there is no autonomy is there. That's why this is not included in the part of the autonomous driving. But when it comes to autonomous driving, there are three types of, we have divided the level of autonomy into three types. Okay, this is actually given by the SAE club. Okay, that is the SAE, the Society of Automated Engineers. So they have come up with this three levels of autonomy. One is the assisted mode, the second is the automated mode, and third is the autonomous mode. So when it comes to the assisted mode, means it's a like collaboratively. The driver would be there in the vehicle. Along with that, some of the tasks would be given to the machine. Okay, so the machine will perform some of the tasks, not all the tasks. You can see the system will perform one of the driving tasks, not all. And in the second, again, this assisted mode is divided into two parts. In the first part, the system will perform one of the driving tasks, and in the second mode, the system will perform several of the driving tasks. So when I say driving task, means it can handle the steering, it can handle the braking, or it can detect the obstacles. There are different. We will see in my next slide what are the different driving tasks that are there. Out of those, if it is controlling one of the tasks, then we can say that it's in assistant mode 1. If it controls some of the tasks, not all, okay, still the driver is incomplete. So you can see driver must permanently monitor that system. Okay, if the driver is completely control of that system, still it is some of the tasks are given to the machine, then we can say that it's the assistant mode. Then the second is the automated mode, where the system can autonomously control the vehicle on defined routes. If some route is given, then it can navigate through that routes. But at the same time, the driver can turn attention away from the road, but must always be ready to take full control again. If some unforeseen scenario that comes and the driver thinks that no, here my whatever the software that is written for the moving the vehicle, my vehicle would not be able to counter that, then the driver can come to the steering and can handle on its own. That is where this automated mode comes into picture. And I would say most of the self-driving car are at this position, level 3 autonomy. Okay, that is where they have come up with a softwares by which they would be able to leave the steering, but at the same time they have the eye on the steering, that if something unforeseen comes into picture, then they can take the steering and take a decision. Okay, then comes the level 4 and level 5 autonomy, where actually the autonomous mode is there. Okay, so the system will be able to perform all the tasks. Like in level 4 autonomy, the system is able to perform all these tasks, but at the same time, the driver can transfer complete control to the system and devote himself to other activities. He can perform other activities in the vehicle itself without thinking about driving. However, he can take control at any time if he wishes. If he thinks that okay, I can take the control now, he can transfer the control. Okay, to the, so it's like two-way. He can, the whole the software stack can itself drive the car. At the same time, if the driver wants, then he can take the steering. Okay, the difference between level 3 and level 4 is that in level 3, if any unforeseen scenario comes, then the driver must have to take the control. But in level 4, it is not compulsory. Level 4, the driver takes the control on his own will. Okay, with so you can say that in level 4, the self-driving car is fully autonomous itself. Just that the driver has given an option of taking the steering. But in level 5, it's like the complete opposite of whatever we see on the road currently. Okay, there is no involvement of human. Humans would be like, if he wants to sleep, he can sleep. If he wants to perform any other activity, he can perform inside the car. Okay, so the vehicle would be able to drive autonomously, and that is where the goal is, to take the self-driving cars to this reality of level 5 autonomy. Okay, so what is this then? So when I say ADAS means it's the Advanced Driver Assistance System. When you think about the brain of what actually controls the vehicle, so this is the software architecture that is there. So as I told you, there would be different sensors that are like the camera, LiDAR, IMU, GPS, radar. Apart from that, there are other sensors too, but this is the basic sensor suite that is generally connected to any self-driving car. From there, the sensors provide the data, raw data that is provided over here. Okay, then there is a module called as perception or situational awareness, where using those sensors, this artificial intelligence or any, we forget about artificial intelligence for now, think about any piece of software that would use the sensors data that is coming out of it, and they will try to perceive the environment. Perception is nothing but perceiving the environment. They will know where the different entities are there in the environment, and they will try to detect different kinds of obstacles. Or you can think about when you run on a road, there are different objects such as this cars, bicycles, or this pedestrians, vans, trucks, all these different objects would be there, right? So this perceiving the environment or the perception part detects them and tries to localize the vehicle with respect to others in the environment, and they will try to predict the scenarios, what kind of trajectory that I should follow so that some unforeseen events should not happen. Okay, unforeseen event can be anything. Okay, it can be fire, what do you say, making an accident, or it can be like something that comes very fast, or some horizontal or let's say longitudinal car comes and collides. It can be anything. Okay, it's not about just detecting an obstacle and go by it. It's not like that. Okay, it can come from any direction in a car, 360 degrees. Okay, that is where this perception part is. Then based on that perception, the data that is coming out of this perception module. Okay, so this, whenever the data comes out of this sensor, that is raw data. But whenever this data comes out of this perception module, it is only the relevant data that is needed, not all the data. Okay, so a self-driving car at 1 minute can give you like 2-3 GBs of data. I will tell you why. Okay, so out of all this data, how much data is actually needed? What is the relevant information that is coming out of it? That is where this perception comes into picture. After getting the relevant information, then the self-driving car uses its intelligence to take the perfect decision. What decision should it take such that in the next move it will be in a safe state? That is the whole game is, right? To make the self-driving car safe throughout the whole scenario. Okay, so the intelligence part and the decision making part, where this intelligence comes into picture and it takes to a state where it reaches to a safe state. Then comes the mission and motion planning things. When I say mission means moving from one place to the other, that is what moving from one location to the other, that is the mission planning. Motion planning means the kinematics parameters. What kind of velocity, what kind of acceleration should it be set so that the vehicle will move. Again, this motion planning is instantaneous, whereas this mission planning is global, right? From point A to point B, something would be given. At the beginning, it will find out, okay, this is the route that I should follow. But while going through that route, it will encounter different scenarios. Okay, that is where this motion planning needs to happen. This velocities and acceleration and the different kinematics parameters that needs to be set. Then this actuation part is there, where actually when you think about a car, the drivers are riding right by the steering. But when it comes to autonomous car, there would be some drive-by-wire component. Okay, there would not be a direct driver that would be driving. There would be some component that would be connected through some embedded system, by which this vehicle can be driven automatically or driven automatically. Okay, that is where this actuation component comes into picture, and that is where we are little bit you have to collaborate with the different mechanical and electronics people to get it done. Okay, so if, as a computer science researcher, my part is basically lies in this perception. Okay, that is where this vehicle, the sensors that are the data that is coming out of this, all these sensors comes into the system, and we perceive the environment. Okay, and my research area lies over here, this perceiving the environment around a self-driving car, then somewhat related to decision making. But when it comes to the planning and actuation component, that is where we have to take the help from mechanical trouble. So it's a interdisciplinary, we can say interdisciplinary research area. Then we will look into why this AI ML is needed. So according to one of the articles from McKinsey Global Institute, AI is contributing to the transform of global economy, which is 10 times faster, 300 times the scale, and 3000 times the first industrial revolution. Okay, so we are in the phase of fourth industrial revolution, which comprises of AI, IoT, and robotics. Okay, and this because of this AI ML only, we are at a stage where our economy is growing faster. Now, so the definite question that should come to your mind, so human race is not new, right? Human race is there, okay, billions of years. So how is this the technology something new? Is this AI ML tells the technology something new? No. The answer is simply no, because AI ML technologies were there in the 1950s too. Even in the technologies that we are currently using, we say about deep learning and neural networks and everything people are using the research areas. It was proposed in 1980s only. Okay, so but why it is growing such a at a higher rate? There are two reasons to it. One is this availability of the data. The second is availability of the higher computing systems. Okay, so in 2008 onwards, there is a trend that came where people were sharing their data. Okay, even nowadays we are sharing the data like anything because of the boom in internet. We are sharing the data like anything, and from 2008 onwards, people started doing that, and there came different data sets by which people will be able to what do you say, use those data to use the neural networks that are proposed in the 1980s and before, and they are able to get the output. But before that, they, even though they have the what do you say, this technology or the not the technology but the algorithm on what to do, but they do not have the data to do it. Okay, so that in after 2008 that happened, then this GPU system, this graphical processing unit system comes into picture, which gives the higher computing to machines, and by which we are able to process those data. Okay, that's why you can see from 2008 onwards it started growing, and from 2014 onwards it's growing exponentially, and now we are at a stage where this AI ML technology is used everywhere, and our this area of self-driving cars is not a exception. It is also using this AI ML to reach to a stage where this self-driving car technology is actually an real what do you say, actually we can achieve that. So there are different terms when it comes to AI ML. There are different terms that comes into picture. This artificial intelligence, machine learning, deep learning. Even some people use them synonymously. So is it really true? Okay. So when if you look into the concept of artificial intelligence is the broader field. It can be any piece of software that is reason that can be used to sense, reason, act, and adopt. It can be any software that is written that will be automatically, it will try to sense why it happened, then it will try to find the reason. Okay, then it will act and again adapt to the system, so that the next time it comes there, it will be able to counter that system. Okay, so you don't have to write a different piece of software to again handle it. This program itself will change itself in such a manner that it or update itself in such a manner that in the next time when it comes, it will be able to handle that scenario. It can be any piece of software. Okay, that is where this artificial intelligence is. But when it comes to machine learning, it is a subset of artificial intelligence which requires the data. If the data availability is there, then only it will call artificial intelligence as machine learning. Okay, so again, the same machine learning also does the same thing. It tries to sense, reason, act, and adopt. But at the same time, with the availability of the data, where artificial intelligence doesn't require the availability of the data. Okay, but when it comes to deep learning, again, it's a very what do you say, narrow subset, I would say, because in machine learning there are so many algorithms that are there. But again, deep learning only consists of the machine learning where the multi-layered neural networks are used with vast amounts of data. We can say that deep learning engines are like data hungry. Okay, if the vast amounts of data is there, and again this multi-layered neural networks are being used, then only we can say that it's a deep learning. Okay, and in the field of what you say, self-driving cars, for processing the data and everything, mostly this machine learning and deep learning models are used, because you see the data is coming out of the sensors, and to process this data, I am telling you that artificial intelligence would be used. As I told you, whenever it comes to artificial intelligence with data, machine learning comes into picture. Okay, and when there is huge amount of data, deep learning comes into picture with neural networks. Okay, so this self-driving car technology mostly uses this machine learning and deep learning. I would not say or, because machine learning and deep learning are different things. Okay, people use it synonymously nowadays, but they are not same. It's completely different. Okay, deep learning is just a subset of machine learning where multi-layered neural networks are being used with huge amount of data. different applications for AI/ML now it is everywhere. I would not give this slide because it is used everywhere. Not only this healthcare or accounting, law, cyber security, military, or self-driving car. It is used everywhere. Okay. So when it comes to self-driving car, as I told you, I showed you one slide where I showed that there are different sensors that are being connected to it. Now the sensors provide the data, raw data that is coming out of it, and raw data is not required. We require only the relevant data. Okay, and the sensors can't directly provide us the relevant data that is required. If that they are providing that, then now there is no concept of research, right? So they are give us the raw data. How to process that raw data to get the relevant information out of it? That is where we use the artificial intelligence. See, the question is, if you have a large amount of data, can the humans automatically go through it and find out the relevant data? That would take too much time, right? That's why I use artificial intelligence. Okay, autonomously, or what do you say? Autonomously processing those data, automatically processing those data to come out with the relevant information in very less time. Okay, that is why this artificial intelligence is huge. So in self-driving cars, different sensors are being connected. So raw data comes out of it, large amount of raw data comes out of it, and then to very within milliseconds. See, when you are thinking about a self-driving car, you have to take the decision within minutes, not minutes, within microseconds. Okay, think about while you are driving a car. So you see, if something comes to your front suddenly, so how you take the decision, how your brain takes the decision. Think about the self-driving car in the same manner. Within microseconds, it has to take this, what do you say, the decision. Okay, so humans can't, human can't see and okay, we need to take this and all those things we can't do, right? So we need some piece of software which would be able to adapt to itself, and that is where this artificial intelligence comes into picture in self-driving cars. Okay, so this slide again I will go through it. What are the different, actually this slide gives you gist of what are the different tasks that are being performed by different sensors that are being connected to an autonomous vehicle. So as I told you, this LiDAR, camera, radar, GPS, IMU, in some cases ultrasonic sensors, all these sensors are being connected to an autonomous vehicle or self-driving car, and every sensor has its own work. Like if you think about a camera, we can think about it as synonymous to the human eyes. Okay, biological sensors. Using human eyes, what do? We try to see the environment and try to find out where this. So we have two cameras connected to its biological sensors, by which we are able to find out the distance in itself. Okay, so in some of the self-driving cars, you will see that there is only one camera that is connected. In some of the self-driving cars, you will see that multiple cameras are connected, and based on that, different research comes into picture. Okay, so for now, you think that whenever you think about a camera that is connected to a self-driving car, you try to see the visual information through in the environment. Okay, then there is different sensors called such as LiDAR, radar, GPS, and IMU. All these have their own what do you say, own working methodology and own tasks that are being performed by them. So in self-driving car, as I told you, huge amount of data comes into picture. Like in one day, a self-driving car can connect 4,000 GB of raw data. And all this data is not necessary. Only some data. If you want to process 4,000 of GB of data for a day, okay, you see, so much time it will take. Need to take a decision. Okay, so we don't require all this 4,000 dB of data. Only few or very, what do you say, only some MBs of data is required to actually process throughout the day. Okay, so how that is done? That is using this AI ML technologies. Okay, so the whole gist of AI ML in self-driving cars is to come up with the relevant data out of those sensors. Okay, the sensors provide raw data. We need to come up with the relevant data that is required to move our car autonomously. So that is where this research area comes into picture, where I already told you perception or situational awareness. Okay, so situational awareness or perception means perceiving the environment around it using different sensors that are being connected. Okay, so the perception part is divided into basically three different components. One is the sense, think, and act. Sense means sensing the environment. Sensing the environment means different sensors that are being connected to the autonomous vehicle collect that raw data. That is where this sense is. Then think based on the make decisions based on the environment. Once you sense it, then you take decision what to do. Once you get the sensor data, you think what to do out of it. Okay, that what to do part is the where this think or the algorithms are there. which comes with the relevant information out of the raw data. Then they provide it to the decision module, which actually acts on it, takes a decision such that the vehicle would be in a safe state. Okay, so there are three different parts: sensing, thinking, and acting. So there are different sensors that, so for that part, the sense part, there are different sensors that are being connected to it. Like this camera, which helps in 2D object detection, semantic segmentation, traffic light detection, lane following, etc. Then there is LiDAR, which gives the 3D object detection and range estimates. Then there is radar sensor, which gives you the velocity as well as range estimates. Then there is GPS sensor, which puts the autonomous vehicle or the self-driving car in the global frame of reference. Then there is IMU Pro sensor, provides the acceleration and gyroscope measurements. We will go through one by one. Okay, in my next slides, we will go through them one by one. For now, you just remember that there are different sensors that are being connected, and you see every sensor has their own work. Okay, so it's not about, see, most of the time we work on research areas where the data is homogeneous, coming out of one sensor data. Either it's an image, or if some people work on this LiDAR, only the LiDAR data, or on text data. Okay, we work only on homogeneous data. But you see, there is this heterogeneous data or multimodal data coming from different sensors. Now, how to use artificial intelligence? That is where this complexity lies in AI for self-driving cars. Okay, again the question is how individual sensors would perform the task. Again, how to connect all these sensors and use the data, fused data together to come up with some decision. You see, whenever you are using some piece of information, you get some accuracy. Now you see, two pieces of information or multiple pieces of information are connected from different sensors, so the accuracy would improve, right? So that is why it is an area where we fuse the data and come up with a decision. Okay, that is why this complexity comes into picture in case of self-driving cars. Okay, so this is how different units or different sensors are generally connected. You will see that generally this radar sensors are being connected over here. Camera and LiDAR would be connected generally at the top to get the view. Okay, in some cases there are multiple cameras connected in such a way that whole 360 degrees are covered. Okay, but in some data sets you will see that only the LiDAR camera part would be pointing to the front, whereas there would be a LiDAR unit which would be moving 360 degree to collect the data. Okay, I will show you. I have a LiDAR with you during this presentation, and some of my slides I will show you that. Then different tasks you see, when it comes to camera, this image pre-processing in generally or processing is generally done, and we perform different tasks such as this traffic light detection, lane flow detection, object detection. Generally the object detection through camera is the 2D object detection we do. But when it comes to self-driving car, 2D object detection is not enough. Okay, because we are moving in a three-dimensional space, so we need to have 3D object detection, and cameras as such don't give you accurate 3D information. We can do some of the artificial intelligence tasks by which we can get the approximate 3D information, but in self-driving cars, when we are moving on an actual road, approximate is not enough. It might lead to some accident or unforeseen scenario. Okay, we need exact information. Okay, so that is why camera itself is not only a reliable not a reliable sensor itself to work for the self-driving cars. We need the help of other sensors. Okay, so apart from that, this traffic light detection and lane flow detection can be done with very high accuracy, up to 99% using only these cameras. Okay, but when it comes to, you see, the most important part is detecting the objects and the trajectories. Okay, so that is where you can see cameras can do the object detection. Okay, but we need another sensor such as LiDAR, which gives the point cloud information. What is point cloud information? It is like you will get points in the 3D, actual XYZ information in meters, you will get it. Okay, and by using that we can directly do the 3D object detection, and that information would be more accurate than the 3D object or object detection that you do in camera. See, we can convert the object that we detected in 2D to 3D by using some calibration information, but I told you, if you are using only a camera, that would not be exact, that would be approximate. Okay, but when it comes to the LiDAR data, this point cloud is exact. Whatever you get the point cloud. What is point cloud? Again, I will tell you in my next slide when I will cover this LiDAR. But for now, you just think that let's say there are different objects in the environment, so you will get some points throughout your environment, saying that okay, this is there is something at that point where I am getting this information from, and that point would be the actual information, the XYZ coordinate with respect to the LiDAR that is connected. Okay, so that is why the object detection that you will do over a LiDAR point cloud would be much more accurate than the cameras. Okay, that's why generally we fuse the data between the camera and LiDAR to get the actual 3D information out of it. Okay, so you can see the 2D to 3D conversion, camera object tracking and LiDAR object tracking all are being connected to actually do the sensor fusion to get actually the final objects with type, distance and velocity. It is not only for one sensor but two sensors connected. Even I'm not talking about radar so much because radar does not come in the what do you say basic sensor suite. Radar can be connected, okay. But again, if you there are some vehicles where the radar is connected. By radar itself, we can do some object tracking, okay. So in that case, three sensors need to be fused. When I say sensors need to be fused, it's not like the physical sensors need to be fused. When I say sensor fusion, means the data that is coming out of the sensor that needs to be fused and come up with relevant information out of it, okay. So you can see this final traffic lights and everything, that is very easy using these cameras. And nowadays there are different sensors that are what do you say different neural networks that are there, which can be able to give you like 99.9% accuracy if the traffic light is visible as such, okay. But when it comes to object detection with their velocities and all the kinematic information and the tracking information, not only one sensor, but you need the information for multiple sensors that are required. Apart from that, there are other sensors too that we will cover, okay. So we'll cover one by one. So when it comes to camera, you know, by using the camera, we can do the 2D object detection. Okay, what is 2D object detection? In the camera plane, those who are working in the domain of image processing, they would know that what is a camera plane. Okay, I will just give you a brief. Like when it comes to a camera digital image, it's like the whole image is divided into different pixels with intensity values. Okay, there is no direct what do you say meters or feet or like that. Okay, it is like pixel information, and whatever the information that you will get there, where this depth component would not be there. It is just only the 2D plane. So whatever the information that you will get on that plane, these objects and everything, that is in 2D. You will not get the actual what is the depth of that object, or what is the actual length or width of the object. Just on the 2D plane, on the pixel plane, what is its size. Okay, and that is not what we need actually when it comes to self-driving car. We need some more, right? We need to know what kind of object it is. That is where this 2D object detection is very, very helpful, to know what kind of object is it, which is where the type comes into picture. But to know actually the what is the length, width and height, and what is the distance that is there, and again at what angle that object is there with respect to the self-driving car, that is where these cameras are not so helpful. That is why we will go to the different other sensors. Okay, but at the same time, knowing the objects is also a very important component, and that is why the 2D object detection using the cameras is also used. Then comes the 2D semantic segmentation. Generally, when it comes to semantic segmentation, it is not about what you say classifying the objects as such on the image plane, but classifying each pixel, what each pixel belongs to. When let's say there's a car, then the other car also is a car, right? Both are cars only. So we do not care whether that's a Volkswagen car, or whether that's a Renault car, or whether that's a Maruti car. We are thinking about a car. So all the cars would be given a different pixel. All the roads will be given a different pixel. All the what do you say greenery objects would be given a different pixel. That is where it is the semantic segmentation. So you can see pixel wise classification is done for the whole image. So each class will be given a different color. Again, here we use different convolutional neural network approaches that are there, and some of them, it's like there is a neural network that is known as deep layer. Okay, you can search on that deep layer. There is a neural network that we can use to do the 2D semantic segmentation. Okay, generally we do the semantic segmentation to find the free space, how the vehicle should move. Let's say I'll show you in the next slide. About this 2D semantic segmentation. So let's say you will find some road pixel which is free, where you can think that your car can move. Okay, so this free space detection we can do through semantic segmentation. Okay, and 2D object detection, I think most of you know about this YOLO network and SSD network, RCNN network, mobile nets and all those things. Okay, different neural networks are there for this 2D object detection task. I won't be going through all these basic neural networks. Okay, because this is a short talk, so I am just going in a superficial way. What are the research areas that is possible out of it? I am not going into the actual research that is there. I am just giving you a hint of what are the research areas that can be connected for AI for self-driving cars. So 2D object detection, as I told you, it actually gives the 2D bounding boxes on the image plane. I already explained you this. Then when it comes to semantic segmentation, you see all the road pixels are given a different pixel. All the using the sky pixels are or the sky pixels are given a different color. All these cars are given a different color. Okay, so there is no segregation between whether it's a car or whether it's a road. All these things. Only all the pixels that correspond to a different class will be given a different pixel. You can see if a self-driving car is moving over here, then it will know where is the free space where I can move easily. Okay, so that is where this 2D semantic segmentation is helpful in case of self-driving cars. Traffic light detection, you see, as I told you, this traffic light detection itself can be done using this cameras itself. We don't require any other sensors. Okay, if the traffic light is clearly visible, then your camera is placed in such a way that this image can come in a greater clarity. Then this traffic light detection is not an issue. There are different neural networks that are currently existing by which traffic light detection can be done easily. Even you can go to this Kaggle dataset where you will find this traffic light detection datasets. Then following the lanes, you see, generally nowadays when the people test the self-driving cars, they do not directly go to the usual roads. Okay, they go to a scenario which is controlled. When I say controlled, means there would not be much vehicle. There would be some vehicles that the people own self-control. Okay, they know where there's a self-driving car that is coming. So that is a controlled environment. And generally, when you think about the self-driving cars, mostly they have come up with some of the tasks by which they are able to follow the lanes, because you see lane following is very easy, because by using the cameras you would be knowing where the lane is, and following that lane is also very easy. Okay, so nowadays most of the companies have come up with this software by which they are allowed to follow the lane, they are able to follow the lane, and that is generally done using this camera sensor only. Using this camera sensor, they try to find out where these lanes are, and they generally try to maintain the car in such a way that it will follow that lane. Okay, that is very easy nowadays. People have come up with different algorithms by which they are able to follow the lanes. So these three tasks, that generally 3 or 4 tasks that are there, that is generally done by the camera sensor. Now when it comes to the LiDAR sensor, okay, so those who do not know, LiDAR is the full form of light detection and ranging. So it's like there would be a laser light that would be going, okay, that is going out of the sensor, and that will go and it will collide with some object in the environment, then it will come back. And the LiDAR will measure how much time does it take for the laser sensor to come back, and using that time and the velocity of light, it will try to find out what distance it is. Okay, that is why I told you, if you remember 3-4 slides back, there would be a point cloud. Okay, that is what is the point cloud is, by that laser signal goes, then collides, then comes back. Okay, and the distance is calculated, and where it collides, there it generates a point. Okay, that is what is the point cloud information is. Okay, so there would be a laser sensor that would be rotating, because we need to collect the data in 360 degree. There would be a laser sensor that would be rotating in some field of view, and generally from the sensors that are there, good sensors that are there, 3D LiDAR sensor. I am talking about 3D LiDAR sensors. Okay, so there would be like minus 20 degree to plus 20 degree. They would be rotating, at like 10 hertz per 10 hertz at a frequency of 10 hertz or 10 times per second, and they would be collecting the data. Okay, so collecting the data means what? They send the laser signal, then that laser signal comes back, and using the time information and the velocity of the light, you try to find out the point clouds around it. Okay, so that is what, when I say the LiDARs give you the point cloud, the data, that is the 3D information. Now you see, when you compare it with the camera, where you are getting only the 2D information, in case of LiDAR you are getting the 3D information, that is accurate again. Okay, so you see, using the LiDAR, what you can do, because it can generate the point clouds in XYZ coordinates. Generally, a LiDAR sensor looks like this in a picture, but I have the LiDAR sensor with me. You can see, this is what is a LiDAR sensor, and this piece of hardware costs around 5 lakhs. And that too, again, the lowest resolution one, because I didn't have that much fund, so I bought this lowest resolution LiDAR sensor, okay, which cost me around 5 lakhs. Now there are different, so when I say resolutions, like in case of cameras, you say that my resolution is HD, my resolution is FHD, my resolution is Ultra HD, and all those things, right? So in case of LiDARs also that is there. Okay, generally the resolution in case of LiDARs is treated as like 16 scan lines, 32 scan lines, 64 scan lines. When I say scan lines means that you remember I told about this vertical information. Okay, how many vertical planes would be there? So you see there would be a LiDAR sensor, there would be a laser sensor that would be rotating in 360-degree and going up and down, up and down, up and down like that, and giving information at 10 hertz. Okay, so that is where this resolution comes into picture in case of a LiDAR sensor. Okay, generally you get the information like this. Generally if I talk about LiDAR, they don't give you the image. This is just a piece of software that is written to get the information. After getting this XYZ information, we are trying to picture that. If you remember about what is a heat map, generally what is you think about a heat map, right? You try to find out which is this which is more affected area. If those who are working in medical image processing, they would know. Okay, so actually is there any direct image on it? No. By using the techniques, you see how what do you say, how affected that area is, and from there on you try to generate the heat map. This is similar to that. Okay, you get the distance out of it, then you write a piece of software by which this distance can be converted into a image. Why image? Because human brain itself is designated for what you say directly working for 30% of visual information only. Okay, that's why to give a better visualization of the data, we convert it into some form of image. Okay, but directly the LiDAR doesn't give you image as in case of camera. It gives you only the 3D point cloud information. Generally, that 3D point cloud is being converted into images to see it. But again, when it comes to artificial intelligence softwares, they directly do not use this image. They use the 3D information that is coming out of it. Okay, that is the XYZ information. So the different tasks, as I told you, using the LiDAR, we can do the 3D object detection, but directly it will give you the X, Y, Z and length, height information along with the angle at which that is there. Okay. Apart from that, there are other informations too that we can see in the data sets that I will cover. Okay. And again, if you compare with the camera data and the LiDAR data, the processing is very high in case of LiDAR, because you see the data that is coming out of it is very huge. Generally, this LiDAR sensor has a what do you say, a range of 100 meters. Okay, so you can see the amount of data that is coming out of this LiDAR, and I would say that because of this LiDARs only, the data that is coming out of this self-driving cars is very huge. Okay, when it comes to camera, that data is not that huge, but when it comes to LiDAR, the data is huge. So you need artificial intelligence software which would be very efficient to process this kind of information. And there are different neural networks like this 3D YOLO is there, like YOLO for 2D, 3D YOLO is there, then 3D RCNN is there. Okay, 3D complexer YOLO is there. All those neural networks that are there, which are able to process this LiDAR information to get the 3D object detection out of it. This is just another example. You can see the objects are being given 3D bounding boxes, not 2D. So these objects that are there in the environment are given 3D bounding boxes. Okay, so they have length, width and height along with some centroid where it gives you the XYZ information. Okay, then the localization. Okay, so if you get, see again, when it comes to the self-driving car, you have some XYZ coordinate, but the XYZ coordinate of the Velodyne is different. Velodyne, when I say it's the LiDAR, okay, generally this company, you see, this company is Velodyne. That's why I've written Velodyne over here. Most of the self-driving cars use that. That is also one point. So they have their own coordinate system. Now the car has its own coordinate system. The cameras will be having their own coordinate system. So we need to bring them to a common coordinate system. That is why this is required from Velodyne to Baselink. Generally, it is like Velodyne to Baselink to map to world coordinates, and all the sensor data we want to bring it to the world coordinates. Okay, then we can use the GPS information that we will see later on. For now, you just remember that the coordinate systems are different, so there would be some research done to bring that data from one sensor domain to the other sensor domain. Okay, this is another example, so I am just going fast because timing is an issue. Then other sensor that is used is the radar. Okay, so the radar is very efficient with low cost and small footprint. If you compare with the LiDAR, the radar also able to give you the 3D information, but you will see that in case of radar, the resolution is very low, but at the same time when it comes to LiDAR, the LiDARs do not work that well in dark and poor weather conditions. Okay, so when you are making a self-driving car, that means it would be able to run in any condition, if whether it's raining or whether it's dark or whether it's any condition, right? But lidars generally don't work very well. They don't give very accurate information when it comes to the dark and poor weather conditions. So in some of the cases, radars are being used as an alternative. When I say an alternative, it's not like completely replacing the lidar. Okay, it's like along with lidar, the radars are being used. Okay, and you use the data from both the sensors to actually come up with the relevant information. Let's say it's a bright day or sunny day, directly lidar data can be used. Okay, again the decision that you don't have to take. Both the lidar and radar data can be combined together and go some artificial intelligence, some software that will automatically decide. Okay, that is what is artificial intelligence, right? It will automatically decide. It will automatically decide whether to use the lidar data, whether to use the radar data, or whether to use the both the data to come up with some information. Okay, so at the end of the algorithm, the whole point is to come up with an accurate information that will make the self-driving car in a safe state. Okay, so again, as I told you, the pros are operates in bad weather conditions, low cost and accurate velocity detection. See, in case of lidar, we can't get the velocity. You have to come up with some techniques by which this range information can be converted to velocity. But in case of radars, you will directly get the velocity information. But when it compared to lidar, it's a very low resolution. Okay, so that's why most of the cases this lidar and radar both are being used to come up with some range information. Then there is GPS, global processing system, a global positioning system is there, or global navigation satellite system is there, which generally helps the autonomous vehicle to put in a global frame of reference. When I say global frame of reference, with respect to others in the environment, you see all these sensors that are being connected to a self-driving car, it's local to itself. It doesn't know where other vehicles are, but at the same time, the vehicle needs to know where the other vehicles are. Okay, so that is why most of the autonomous vehicle companies, what they do, they try to bring their autonomous vehicle in global point of view. Okay, that is why in every autonomous vehicle you will see that there would be some GPS connected. Okay, by using that information, they would be able to know where others are there in the vicinity. Okay, so that they can take some accurate information, accurate action to what do you say, to accurate action in future, so that some unforeseen scenario could not happen. Okay, then there is another sensor known as inertial measurement unit, or IMU sensor, which generally gives you the acceleration or the gyroscope data. Okay, when it comes to acceleration, means at what speed the vehicle is moving, then gyroscope means at what heading it is moving. Okay, so both these data are required to come up with the accurate kinetic parameters or kinematics parameters, so that you can find out the trajectory, at what trajectory to move, and find out the trajectory of others in the environment, because you don't know what is the IMU information of others in the environment, right? So if you know that, let's say distance and all those distance or range information, then or velocity information, because using the radars you can get the velocity, and using lidar and radar you can get the range information. Now let's say you know the IMU information of the vehicle that we are currently considering. Okay, generally the autonomous vehicle that we are driving is known as the ego vehicle, and the vehicles that are there in the vicinity are known as the target vehicles. Now let's say you want to find out the accurate kinematics information of the target vehicles. Then what you can do, you can use the IMU information of the ego vehicle and use the range information of range and heading information of other vehicles, so that you can find out the IMU information of the others. Okay, so that is why IMU is also very helpful. Okay, so I am just giving you what are the different basic sensor suites that are connected to an autonomous vehicle. Okay, generally this camera, lidar, GPS, radar, IMU are the 5 different sensors that are being connected to any autonomous vehicle. Okay, that is, then comes the multi-sensor fusion part. So as I told you, the data coming from a single sensor can give you some accurate information, that's some accuracy. But when you connect both of them, like this lidar radar fusion I told, okay, in some of the cases lidar can work very well, in some of the cases radar can work very well, and who will decide? That is where artificial intelligence will only decide. That is why generally this lidar and radar data both are being given to a software which automatically decides which data to use. Okay, and again, if needed, can you use both the data? Can we combine both the data? That is where this fusion comes into picture. Okay, and generally we will see that the camera lidar fusion and lidar radar fusion are the 2 basic approaches people use, because in case of camera okay, in case of camera you will get the 2D object detection, and the types that of different objects in the car, and using this LiDAR you will get the 3D object detection, and types somewhat you will get the types but not accurate. So you see, using both the information you will come up with some information that is very accurate. Okay, so generally this Kalman filter and unscented Kalman filters are being used to combine the data of the camera and LiDAR. Okay, so you can move from one plane to the other. As I told you, these LiDARs have a different coordinate system. These cameras have a different coordinate system. Again, they are connected at different places on the vehicle. So there would be some metrics. Okay, that is what is known as external calibration. Okay, you know about internal calibration, camera calibration, LiDAR calibration, everything. But when it comes to external calibration, means two different sensors. How to calibrate between them? Generally, those calibration information is being used to move from one plane to the other. Okay, because at the end of the day you need the information with respect to the vehicle, not through the camera plane, not to the LiDAR plane. You need with respect to the coordinate system of the vehicle, and they all of them needs to be brought to that plane. Okay, so that is where the sensor fusion is being done, and the data are being brought to the common coordinate system with respect to the vehicle. Okay, so that is where this generally we do this research area which is known as 3D multi-object tracking using camera and LiDAR. Okay, using this camera and LiDAR, you fuse the data, do the detection, then again do the tracking. Tracking means the getting the identification number of different objects in the vehicle. If you have seen a car which is, you are telling that it's car 1, then throughout the scene which is it is visible, you should say that it's car 1 only. Or if there's another vehicle, you are saying that okay, it's the car 2 that I have seen, then throughout the scenario that you are seeing through the autonomous vehicle sensor, you should say that that is car 2. Okay, that is what is tracking. It's giving a unique identification number to different objects in the environment. Okay, so that is where this camera LiDAR fusion is very helpful. Okay, this is one paper that I will show in the demo. Then again, as I told you, LiDAR, radar fusion can be done to get the accurate range estimates and velocity estimates. Okay, so depending on different weather conditions and different poor visibility conditions, LiDARs cannot be used, only radars can be used. Again, it's a very bright day, LiDARs can be used. So at different places, LiDARs and radars can be done, can be used, what do you say, depending on their usage. But at the same time, in some cases, LiDAR and radar can be combined together. Okay, like LiDAR can go and give only the, what do you say, the range estimates, or the range information, length, width and height information, or the distance information. But radars can give you accurate velocity information. So you see, by different sensors give different piece of data, then you can combine them together to come up with accurate information out of it. Generally, again, these Kalman filters are being used for that purpose, and I am not going to go through the details of this diagram, because this is just a what do you say, flow chart. Like either LiDAR can be used, or radar, or combined can be used through a filtering mechanism, and it depends on the different Kalman filter. There is a concept called as Kalman gain and all those things. By using that, we can filter the data and we can use the data out of those two. Okay. And different data sets that are there, if you can open this, I will just open a website or this KT data set that we generally use. Okay, KT data set. If you can open, you will see that all this different sensors data that are there, like this LiDAR, radar, GPS, IMU, all this data that is coming out of there, shared it. Okay, raw data, if you go, you can download it. Then this generally these data sets, what they do, they perform some kind of competition. Okay, where people using some accuracy metrics, they process this data, and using some accuracy metrics, they put on the website. Okay, so you will see that there are different. One second. There are different leader boards. Okay, for different tasks, you will see that there are different leader boards that are there. One second. 3D object detection. Let's say I am going to 3D object detection. You will see that there would be a leader board where people would be putting their algorithms. Okay, they would say that, let's say this algorithm that I am talking is the top. Okay, based on some accuracy metrics, they are saying that they are getting the 3D object detection from the LiDAR to a very accurate manner. Okay, so these sites you can follow for different data sets. Like this KT data set is the benchmark suite data set, which started in 2012. Now there is another data set that has come up, the second version, this KT 360. Okay, this is the latest data set that has come out now itself in 2022 only. Okay, so you can go through all these data sets to know about this area of research. Then there is this new scenes data set is there, Waymo data set, Argoverse, so different data sets are there. But one data set that I want to cover, want to tell you that IDT data set, Indian driving data set, which is proposed by IIT Hyderabad. Okay, so they have taken this, generally these data sets that are there are from different foreign scenarios, and most of the algorithms that we run does not work for Indian scenarios, because you see how the neural networks are being made, they are like biased. Okay, so for Indian data sets, so we need to what you say, train the neural networks or the artificial intelligence networks that are there with the Indian data sets, and this, for this IIT Hyderabad has come up with a data set known as IDD, or Indian driving data sets. Okay, and in all the data sets you will say that they are doing some kind of competition based on the accuracy metrics. So this 2D object detection tracking, 3D object detection tracking, lane following, lidar image segmentation, and all this being are done through different data sets. And you open the data set, you will see that for every task they would be having some leaderboard. Okay, where people put their algorithms, and using some accuracy metrics they put them with respect to their position. Okay, so the position one would be generally the ones who provide the very good what you say, algorithm. Okay, so if I start a research area, I generally, what I do, I go to these data sets, I try to find out what are the algorithms that are there, I try to run them, then I will know what is the problem with all those already proposed, and then I will find a area where I have to work on. Okay, that is how I found the research area in this domain. Okay, so demo again I can show, there's a video that I have made. So this data again you will see that I have taken this data from the Kitty data set only. Okay, so you can see this is the camera data that is coming out of it, and this is the lidar data. But you can see in this camera plane itself I am able to draw the 3D bounding boxes. How? Okay, so in camera plane it is not able to actually get the 3D information. But what I have used, I have done the sensor fusion. Okay, so this using this lidar data I am able to get the 3D information. Using this camera data I am able to get the 2D information. Now using this external calibration I am able to project this lidar data onto the camera plane. Okay, it's not like direct projection. There are some external calibrations that you need to do, because the position of the camera is different from the position of the lidar. Again, the coordinate system of the camera is different from the coordinate system of the lidar. So there would be some transformation that needs to be done. That is generally known as I told you, external calibration. And generally these data sets would provide their external calibration or the matrices. Generally that would be matrices. Okay, so using these matrices you can directly would be able to convert this from the one to other. But if you have your own lidar sensor like me and your own camera sensor, then there is a research area by which you have to convert and you find that calibration information between them. At the same time, you can see this position X and position Y. There you can see if some vehicle is moving, that ID is remaining same. Like this vehicle, which is this ego, as I told you, the vehicle that I am driving, or the vehicle for which you are concerned. And there is a vehicle that is going in front of this vehicle. You can see this 2. And throughout the scenario, you can see this number 2 is not changing. That is what it means. It means that it is able to track that vehicle. Track means that you can see it. If it's a person X, then that is person X throughout the scenario. If it's a car X, then it is car X throughout the scenario. So you see this tracking is also happening. Okay, in this. So using so if you go to these data sets, you will find all the relevant information to convert from one to other, and how to get this tracking information. Again, this is a very good research area which is known as multi-object tracking. Multiple objects you can track on this go. Okay, in one go you are able to track multiple objects. Okay, then again 2 areas, 2D multi-object tracking when you do only on the camera plane, 3D multi-object tracking if you do on the 3D coordinate system. So all those things are there. Okay, so if you go there, then you can run some of the existing algorithms there. You will get some idea about what is the research area that you should work on. Okay, so this is the demo that I have. Okay, and this I covered. Okay, so this is what I wanted to discuss in this webinar. And apart from that, as you know, my research area is in this machine learning and computer vision for autonomous vehicles. Okay, any autonomous vehicle. It can be a self-driving car, it can be humanoid robots, or unmanned aerial vehicles, or underwater vehicles. And PhD, and I have 2 projects, one under the DST and one under the Tihan IIT Hyderabad. Both are on self-driving cars. And there are different positions open, JRF and project scientist positions are open, and PhD is also open under me. So those who want to apply, they can apply. Currently this project scientist position is live. Okay, if you go to IIITDM website, you can find that link and you can apply for that. And for PhD positions, when the IIITDM, as it's a centrally funded technical institute, when it opens, you will have the option to apply, and after the interview, you can get selected. Any doubts, you can send me a mail and go to my profile link to check. Okay, so this is what the presentation is about, and if you have any doubts, I am happy to answer. Yes.
Do we have any questions from the audience?
Because of the time constraint, I had to go a little fast at the end, but I think the whole research gist that I wanted to tell, I think it's clear. So if you have
Yes, sir,
any,
yes.
yeah,
It is no
any
issue.
queries, I am happy to answer.
Things were pretty clear.
Okay.
So if there are not any doubts from the audience side, I have a question. So,
Yeah, yes.
so you take all this data from the sensors and you process them and you calibrate them externally to get a common input sort of a thing. How do you deal with noisy, like there could be noisy measurements because of, let's say, climatic conditions like extreme wind or heavy rainfall or things like that?
Yeah, so that's why this, as I told you, the sensor fusion comes into picture. Different environments, different sensors give accurate information. Like this lidar, radar example that I gave. Lidar can work very well in like very brighty scenarios and lighty scenarios. But when it comes to this rainy scenarios and foggy scenarios, it might not work that good. That's why these radars are being used. Okay, so radar can work in this different what do you say, adverse conditions. Okay. But at the same time, the resolution is very low. So every sensor has its own advantages and disadvantages. But if you can use both of them collaboratively and come up with some techniques which would fuse the data, then you can work in different scenarios.
Okay, and like most other real world applications, the deep learning part is only used for the big data processing, and we also can use traditional machine learning techniques like surf features, or you mentioned Kalman filters. So those are not DL techniques, those are
No,
traditional
those are
ML techniques.
machine learning, traditional ML
Machine
techniques.
learning techniques, yeah.
Hmm.
So we do solve problems, and as of now also using sophisticated problems like UAVs, using traditional machine learning techniques, and the big data processing is just delegated to the deep networks.
Deep learning part, yeah. Yeah, same. If required, then only we should go for deep learning. But if we can do like this simple tracking things, we can do using just optical flow algorithms using cameras.
Obviously.
Okay, so we do not have to go through that. But when it comes to like big tasks such as object detection and all those things, then we have to go through this deep learning part where huge amount of data is required.
Yes. Okay. Obviously, because if we do not need that much of processing, we should, until we need
Yeah.
that, we should not, we should refrain from using.
Yes.
Okay, thank you so much, Ram sir. Personally, for me, you have been a very big inspiration. With I used to see you in front of the department with your drones and your quadcopters and all that, and I used to be heavily inspired. I hope
Thank you.
members of our audience were also inspired, and I would like to extend my vote of thanks to you and all of the members who are present today, respected head of the department, ma'am, Professor Dr. Devavati Mishra, ma'am, and all my colleagues, all the students of this department who have this and other departments who have joined here. Thank you, all of you, for joining and sharing today's session. I hope you all had a lot of, you understood a lot of things about this area, because Ram sir is a really good researcher, is what I have always felt. So that is why I had this idea of inviting him. Also, thank you, Ram sir, for taking time out of your busy schedule on a Saturday. Thank you for sharing your amazing, inspiring work with us. Thank you so much again. Having said that, I would like to end today's session. Thank you, everyone. Have a wonderful Sunday. Goodbye. Namaskar.